Okay, welcome back to CE 526. I want to go over the, the piece of code that I had shared with you guys to help you in developing that negative binomial regression model for it. So I want to go ahead and talk about that code that I shared with you as to what's happening in that code. And maybe there are some common sources of error that I noticed during my office hours. I want to make sure that I go over that. And then I will open the Zoom rooms for individual groups to work on their own projects. Okay, so let me go ahead and load that page here. Okay, it looks like. So I'm going to go ahead and share my screen. Okay. So I'm going to Okay, so I opened this. So this is funny, right? So just one thing I want to point out. I was looking at an older link, and they used to do this using another package that I used to use. It's called SAS, and SAS is another programming language that folks use, and I used it quite a bit for my graduate school. And now they don't have that link anymore because people are switching to more open source stuff, and R obviously is one of those things. So okay, so I'm going to go ahead and share my screen here. I'm not already sharing it. Yeah, I'm not sharing it. So okay. So this web page talks about negative binomial regression, R data analysis examples. So first thing right off the bat, negative binomial regression is for modeling count variables, usually for over dispersed count outcome variables. So count outcome variable that they talk about in this tutorial is about number of days students are absent from their class. Okay, so they're trying to model the count of days students are absent. What is our count data variable? Our count data variable that we are interested in is the number of crashes. So our dependent variable, the Y variable in the regression model, will be count of crashes. For them, it was number of days students were absent. Now, one thing that you'll have to do is that if you're going to use any R programming, so make sure that what they say as required, you make sure that you install that package, install packages. So you make sure that you install all of those required packages. And not only do you have to install it, then you have to call it also. And how do you call it? You call it by using, instead of require, you call it using the library statement. So library foreign, library ggplot2, library mass, right? So you have to, if your package is not installed, you have to install it. And remember the difference between an install.packages syntax and the library syntax is that there is a quote when you install the package, but when you load it by using library statement, you don't put the quotes. Okay, so just make sure that this could be a source of error. Make sure that you can have, so maybe that might be one thing that you guys do along with me. So maybe take a minute to make sure that you guys are able to install these packages and are able to Now, you probably already have them installed, some of them anyway. But if not, then you could just rerun the install packages line. And then once you have that, make sure that you load the packages by using the library command. So instead of require foreign, you'll just do library ggplot2 or library foreign or library mass. So I'll just make sure that I include that in the chat window here. So the way you do it, and remember, there are no quotes when you do the loading, but when you do the installing, install.packages, then you need the quotes around the package name. Okay? So make sure that you guys at least do that piece, and you can do that. And if you're installing packages, it might give you a bunch of like red text, and that red text you can safely ignore. That's not an error. It's just kind of, you know, running through the installation process, and you can let it run through that. Okay, so the example that they are studying is basically high school juniors at 2 school, and they want to look at number of days of absence, including the type of program for which student is enrolled, and a standardized test score in math. So they want to use it. So they have two predictor variables: standardized test score in math and the type of program that student is enrolled in. For you, the predicted variables would be AADT, and there might be more, right? So you would have like maybe ramp configuration that you created. You might have ramp configuration. You might have curvature, whether there is a horizontal curve or not. And like maybe, I know some of you talked about presence of billboard, whatever it is. Like, so there could be, so what's the difference between AADT and curvature, for example? AADT is a continuous variable, and curvature would be a sort of a categorical variable or a nominal variable, because it'll have categories rather than just kind of numerical values. Okay? So in this case, they have standardized test score in math, that's a numerical variable, and type of program in which the student is enrolled is a categorical variable. Okay? So I hope you're able to see the analogy between the type of data analysis they're talking about versus the type of analysis that we are doing. It's the same data analysis, it's just that our dependent variables and independent variables are different. So I've typed up some predictors. So our predictors would be ADT, ramp configuration, curvature. Now what they do is like once they, so this first piece of code that they talk about, example 1, what they're doing is they're basically not doing much. They are just reading the data. Essentially, they're reading the data through that first line of code. And that data is not really available, so I couldn't show you what the data looks like. But all you're doing is, like you read the data in your assignment that was the Advent hour calendar, or what you did for your TIMS lab, you read the data that was in the CSV format. Now, if your data is already in the CSV format, that's great. You can convert an Excel file into CSV format. You can save it as, or you can search the internet to see how do you import an Excel file. So this is just all that's happening here is just an importing of an Excel file. What's happening in the next step is sort of a little bit interesting, but maybe not directly applicable to you guys, but something to note, something to learn. What's happening, what I'm highlighting here, is that they have in their original data set, they have a factor called PROG. They have a variable called PROG. They have a column name that's called PROG, basically referring to the program. And that program is numbered 1, 2, or 3. Now, if you give any programming language a variable that takes the value 1, 2, or 3, one of those values, The program is going to think of this as like, okay, this is a numerical value, right? But what this piece of code is doing is basically converting, like using the factor or using the function called factor, the variable prog that exists, that 1, 2, and 3, it's telling the program that, hey, that 1, 2, 3 is actually levels of a nominal variable. And I want you to label if the variable prog takes the value 1, then you call it general. If it takes the value 2, then you call it academic. And if it takes the value 3, then you call it vocational. Okay? So it's making sure that you're assigning the factor prog to make sure that the R, when it reads that as a numeric, it's a categorical variable, not as a numerical variable. Why is that important? Because numerical variable, it'll be treated in the modeling somewhat differently. Or when you do, like, let's say you want to summarize a numerical variable, it will kind of give you like mean, mode, median, 50th percentile, 25th percentile, things like that. But those types of things are meaningless in the context of a categorical variable. So all this code is doing right here is taking the variable prog and changing it from values of 1, 2, 3 and making sure that, hey, please recognize this as a factor, not as a numerical variable. And then also it's doing the same thing to the variable called ID. ID will be your segment in your case. In this case, ID was the student ID. In the second line of code, this piece of code, what this is doing is converting ID into a factor. And because you don't need any levels or anything like that with that, you want to just convert, make sure that IDs that are like 1001, 1002, 1003, like this, all these IDs are recognized also as a categorical variable or as a factor. So factor basically takes numbers and makes sure that R treats them as a categorical variable. And so when you do, so you might want to factor your segment numbers that I provided to you as IDs, or not as ID, as a factor, so that R doesn't go ahead and looks at, okay, maybe I'll try to predict crash frequency based on like how I talked about segment number 1 to 19, right? That will be a meaningless predictor because you want to make sure that it's like basically just one segment. So does that sort of is clear about what's happening here? Any questions about this? Okay, not hearing any questions or hands raised. You can type up questions via chat as well. Okay. And then this last piece of code is just doing the summary of the data. And now you could see the variables that were already in like female or male format, they automatically get recognized as factor, and are just, when you do the summary of the DAT, the data where you read your data, the element called DAT, when you do the summary of DAT, the factors that are like in text format, the variables that are in text format like female or male, it automatically gives you the frequency. The factors that are number, it will automatically, so for example, for math, it gives you minimum, first quartile, median, mean, third quartile, and maximum value. So it kind of gives you the standardized test score and then days absent from 0.0 to 35. What's the first quartile, median, mean, third. So any variable that's numerical, it kind of gives you, for these two, it gives you these details. And remember, prog, we make sure that we converted that into factor, and then it tells you like the relative frequency of each of these three, or the frequency of each of these three modes, the general, academic, and vocational. So there were 40 students that were general. And here you might want to identify how many, for your data analysis, you might want to identify how many segments of curve you have, how many segments of, where the RAM density exceeds a certain value, whatever your variables are, you can get that information using summary of the data. Okay. Then they kind of generate a plot This plot might be helpful to see if there is any correlation between crash frequency and any of the other things. So they're looking at, like, for example, they are looking at if general, academic, or vocational student. So this GG plot basically generates the frequency of days absent, like how many counts of days absent, and how does that correlate for each of those categories. So you will see that 40 of the students in total have 0 days absent, right? But 30 of them are basically vocational students. But among the general students, there were no general students that had 0 days absent, because that's why this number here is empty, right? Because there's no bar here, the bar for general. So basically, it's categorizing the data based on general, academic, and vocational, and contrasting it with all. So you can, in a chart way, you could see what is the frequency of crashes in each segment, in all segments, 1 through 19. Okay, and like, if there were like how many segments and how many crashes that occur, and then you could look at it for each category of the enrollment type: general, academic, and vocational. That's obviously, it's not a required step for your analysis. This sometimes is helpful in visualizing things like you did in the previous lab. So that's something that, I'm not real interested in. What I want to make sure that if we go over the analysis you might consider, and then this is what I'm interested in. So negative binomial regression model is basically trying to fit a best fit line on crash counts, and negative binomial regression can be used for over dispersed count data. Okay, and what do I mean by over dispersed count data? If you recall from our empirical based tutorial, we had something we called over dispersion parameter, right? Over dispersion parameter. That over dispersion parameter was the thing that we used to decide how we want to, how are we going to, how much weight are we going to assign to the model output, if you call that. And that over dispersion parameter is used because count data can also be modeled using the Poisson's regression, right? And Poisson's is a distribution where average of the distribution is supposed to be the same as the standard deviation of the distribution. But sometimes in crash data, the standard deviation really is higher than even the average of the data. And that happens quite a lot with crash data. And that's why we use the negative binomial regression model, because the standard deviation of crash counts is generally higher than, so that's why we call the crash data to be over dispersed. And because crash data are over dispersed, we use the negative binomial regression model. Yeah? So how do we do negative binomial regression model? We do it using the mass package, which should already be installed and loaded. And all your real code that you need to write is this piece. Summary of M1, glm.nb. So the funny thing is that you read the code sort of a little bit backwards. So your last statement that you're using, the function that you're using is glm.nb. So glm.nb is a function that estimates the negative binomial regression model. And GLM stands for generalized linear models. And generalized linear models are the models, it's a class of models under which falls the negative binomial regression model. So we're just doing glm.nb. Instead of days abs, you will use the variable name that you have for your count of crashes. And this tilde is basically showing this y, this is the dependent variable. And then this kind of is like an equal to sign in the regression equation. So you'll use this tilde. And then math plus prog. Math is the variable that represents AADT, for example, so instead of math, you'll use AADT. Plus prog is the program name. And then instead of PROG, you will be using what? You will be using curvature. You'll be using any variables that you have related to ramp characteristics for US 101 segments and so on and so forth. And then this last piece is data equal to. So instead of DAT, you will use the data table that you have, the data frame that you've created based on importing your CSV file. And ultimately, once you run this, all of that goes into like an output called list. It goes into a list called M1. And then when you do summary of M1, which is basically the output of the negative binomial regression model, the R will give you this output right here. And what I want to get from this is this piece right here. It's very important. Okay, so this piece basically telling you what is the coefficient that you're getting and how significant are those coefficients. So the first column estimate gives you, like, this is sort of like, the coefficient of X values, like you see in the best fit line in Excel, right? But now obviously it's much more complicated than a simple best fit line between two variables. But this basically is the intercept. And then math gives you like a negative coefficient. Prog academic gives you so what does this mean? That means that higher the score in math, the lower the days absent. So these two things are correlated. So you could predict the number of days absent by using the math as a variable. And so if math score goes up by 1 point, the number of days absence go down by this value. If the math score goes up by 20 points, then it's like, it's 20 times this is the increase in your decrease in your, and the negative sign says decrease, right? So that sort of implies a negative correlation. And we are also interested in this last column because last column gives you the p-value. The PR greater than Z is basically the p-value. P-value tells you how significant the variable is. If the variable, the p-value is less than 0.05, then that means that your variable is significant at the 95% confidence interval. If the p-value is, so this sort of like these asterisk mark tell you that. So one asterisk means it's significant at 95% confidence interval. It's 0.05. If you see a double asterisk, then it's significant at 99% confidence interval. If it's less than 0.001, so you'll see a triple asterisk like you see here. And that means your variable is significant at 99.99%, 99.9% confidence interval. Okay, so you will be interested in finding out which of the variables are most significant in your model ultimately. So you might have to run multiple models. And then for each model, you will be interested in this, looking at this last one, the AIC criteria. And when time comes to select, like, okay, you might estimate like 5-6 different models, but you want to find which is the best model. The best model will be identified based on whichever model gives you the minimum value of the AIC. Okay, so my advice to you now would be try to see if you can generate this output. And then once you generate this output, see if you can make sense of this. And also they provide some descriptions of what I just talked about. So you might want to read through that. And there is something interesting about like how you interpret the negative. So I just talked about how do you interpret math coefficient, but it's interesting how you interpret the coefficient that exists for the nominal variable. Now remember, nominal variable, you won't get like just one coefficient. In fact, you're going to get however many categories you have, you'll get one less coefficient than that. Basically, because what happens is that you decide one of those categories, the R decides that one of those categories would be the base case. So in this case, the category general is the base case, and the two categories, vocational and academic, are compared to that base case. So what this tells you is that if you're in the general category, so for example, if you're in the vocational category, you will have lower number of absent days. If you're in the vocational category, if you're in the academic category, you will also have lower number of vocational cases. And these negative 0.44 and negative 1.27, they measure how much fewer absent days would you have if you are belonging to vocational category compared to a general category. Okay, and all of this description is in fact provided here. So I would recommend you reading through that. and trying to make sense of that. But if it doesn't make sense, obviously ask me a question there. Okay. So that's all basically what you need to do in running the model. And so once you show me these coefficients, this is basically what your safety performance function is, right? Once you show it to me for your data on crash count, this highlighted piece is in fact your negative binomial regression model. And I think they should report the theta, which is this theta is your over dispersion parameter. Okay. So I want you to report the theta and this table like this. And this table is in fact your negative binomial regression model, or your safety performance function that I'm interested in. Okay. So I know that's a lot to take in, but my advice would be to try to see if you can get any kind of an output like this for your data. And then let's talk about if you need help interpreting it. And if you guys are already there, that's great. So first, let me ask you guys, are there any questions on the discussion? Anything that you that you want me to sort of repeat, or if there is anything that that's not clear? I know that's a little bit a lot to take in. But let's see if you can make use of this information. Are there any questions at all? You can ask in the chat, or so your goal right now is to see if you can read the data. So absolutely essential elements will be reading the data and then making sure that, you know, whatever factors you want as nominal variables, you kind of do like a factor function. Even if you don't like label them or make them look nice or whatever, it doesn't really matter to me. Ultimately, it might look nice in the model output, but what I'm interested most in, like, you know, at least convert whatever variables you want as nominal variables as opposed to like direct numerical values. You want to make sure that you convert them into factors. So this is sort of important to me, this piece of the code in your data. And then once you do that, then you can come down here and do this with your data, this last piece, and generate a table like this. So make sure you can do that. And let me, and I want to be able to open, if there are, unless there are further questions that you want to ask as a class, I would welcome, you know, I would just go ahead and open the breakout rooms where you can then work with your groups to sort of finalize what you're working on and ask for help. Amanda couldn't be here. She was supposed to be here, but she was having some health issues, so she couldn't make it today. But she's available by email, but also like I'm here. So I think I should be able to help out as well. So why don't you go ahead and start looking at the data analysis, and I will go ahead and open the breakout room. I'll go ahead and stop sharing first, and then pause the recording here too.